Hi everyone. Now we are going to discuss on a single phase fully controlled rectifier with a resistive load. So in the system you will be having four thyristors will be there from T1, T2, T3 and T4 which are named as shown here, that is this is T1, this is T2, T3 and T4 are there. And you can see that the thyristors, the upper half thyristors cathode are connected together and lower half thyristors anode are connected together, and you are giving a supply source from this particular point. So I am going to name this particular point as L and this particular point as N for our ease of explanation. So during the positive half cycle from 0 to pi, you can see that this is from 0, this is pi, this is 2 pi, this is 3 pi and 4 pi. So from 0 to pi, you can see that the thyristors T1 and T2 are forward biased. Since the thyristors T1 and T2 are forward biased, if you are giving a triggering pulse or a firing pulse to the thyristors T1 and T2, then both of them get switched on, and therefore your current will be flowing from the point L, then to T1, then to the load resistance R, then T2, and coming back to N. So that is how the system is going to work during the positive half cycle. And the triggering pulse can be given at any instant of time from 0 to pi. And here I am going to trigger my thyristor at any angle alpha. So I am giving my thyristor firing angle at over here. So that means this is nothing but your angle alpha. So how your output voltage will be looking? So I will plot the output voltage V0. So since it is being fired at this particular point, I can draw the output waveform like this from 0 to pi. T1 and T2 are conducting. So this is the period for T1 and T2. Now you can also see that the current, how the current will be behaving. The current is also going to behave in the same manner as your output voltage V0, because that is the resistive load. So both of them will be in phase with each other. So I will plot my current I0. So I0 will be also of the same manner like this. Now at pi, what happens? Both the voltage and the current has reached to 0, and after pi the voltage is going to the negative side. That means the thyristors T1 and T2 gets reverse biased, and since the current has also reached to 0, therefore the thyristor meets its specifications in order to get it turned off. So T1 and T2 will get commutated by itself. Now during the negative half cycle, here you can observe that during the negative half cycle the thyristors T3 and T4 will get forward biased. So therefore the current will be flowing from the point N, T3, R, then T4 and back to L. So here the current flow will be the same direction as it before, and the voltage is also of the same polarity. So therefore I can again draw my output waveform from pi to 2 pi like this, and for current also in the same way. So I'm going to fire my thyristor like this. Now, here I just need your attention. We can also see that in the first case, so here I will note it down. This is for T3 and T4 is conducting. Now here also you can just have an observation of the over the current IS. That is nothing but the source current. Here the current is going like this. The source current during the positive half cycle, that is from 0 to pi, if anywhere I am firing my thyristor into the on condition, the current is flowing from L, T1, I0, R, T2 and N. So the direction is from left to right. Now just see that during the negative half cycle, T3 and T4 is triggered. So how the current flow is going to happen? From the point N, it goes to T3, then it goes to R, then it goes to T2, T4, and then goes in the direction opposite to the direction of convention we have already mentioned here. So IS is opposite to your actual current flow from angle pi to 2 pi. So therefore I can plot my current IS as, it will be same as I naught from 0 to pi, and from pi to 2 pi, if I am firing my thyristor at a particular angle, then it will be in the negative half cycle like this. So I can again complete the entire duration like this. You can also complete the duration like this. So this is how we finish off with the working principle of a fully controlled rectifier with a resistive load. Now we can also do the analysis how we can find out the average output voltage and the average output current and the RMS value of output voltage. So first we are going to define the output voltage equation. You can see that the time period of your output voltage is pi. So therefore your output voltage V0 will be 1 by pi, that is 1 by time period is nothing but pi, so it is 1 by pi integration from alpha to pi Vm sin omega t d omega t. So therefore I can write it as V0 is equal to 1 by pi integral alpha to pi Vm sin omega t d omega t. So you can solve it and you will getting your answer as Vm by pi into 1 plus cos alpha. Again I can write I naught is nothing but Vm by pi r into 1 plus cos alpha. We can also think back about our half wave controlled rectifier with the resistive load. There the difference was the time period was different. Where it was 2 pi was the time period. So 1 by 2 pi we get and from alpha to pi. So you can see what is the change in output voltage equation I naught under this condition. And Vrms is given by root of mean of the square of the individual values. So it is 1 by pi integral alpha to pi Vm square sin square omega t d omega t on 1 by 2. So again you can solve the same equations and you will be getting it as Vm into pi minus alpha divided by 2 pi plus sin 2 alpha divided by 4 pi all raised to 1 by 2. Also Irms is nothing but Vrms divided by R. So we have arrived at 4 equations. One is for V0 and another one is for I0, then Vrms and Irms. I haven't done the step-by-step calculations because in a lecture like this I don't think that step-by-step calculation is not required, as integration, basic integration is known to everyone. So this is how the complete working of a single phase fully controlled rectifier with resistive load. So always whenever you do this, always compare it with the half wave rectifier also in order to get what are the differences it comes into picture in such cases. So here as an assignment you can also do to draw about the voltage across the thyristors when the thyristor is in the on condition and also in the off condition, which we have not plotted down it here. And actually you can also complete it like this. Okay, thank you. Now we are going to discuss with a RL load in the next section.